Okay, here's your lesson for tonight. It's a total of 9 slides, 10 if you include this one. You can do these on your device. Make sure you are typing it into a note-taking app, or you can handwrite it. There will be no screenshots allowed. There are a series of math problems and review questions at the very end. You will be turning these in on Wednesday, so please make sure you do those on separate sheet of paper. Come on, there we go. Okay, motion occurs when an object changes its position. We talked about that in class a little bit today, but not a whole lot. As long as something goes from point A to point B, even if it's just a centimeter, that means motion has occurred. A reference point, or a frame of reference, is an object that is stationary like a mailbox. It helps you determine how far an object moves. The most common frame of reference or reference point is the Earth itself. Okay, distance is how far something moves, and displacement is the distance and the direction of an object's change in position from the starting point. Speed is the distance an object travels per unit of time. It's how fast the object is moving. It's a rate of change in position. Any change over time is called a rate. The formula for speed is distance divided by time, and in here we'll be using the meters per second unit. You need the first, second, and third bullets on this one. You need all three of these. Constant speed is when the speed of an object does not fluctuate. It's when the speed stays the same over a period of time. It's like your parents when you're on a long car trip when they put the car on cruise control and they go down the interstate at exactly 58 miles per hour for however many miles. Average speed is a description of the speed of motion when speed is changing. So from your house to the school, you might, when you're leaving your neighborhood, get up to 28 miles per hour. On General Booth Boulevard, you might get up to 50 miles per hour. When you are going down Nemo Parkway, you might be at 60 miles per hour. But then when you go into the school zone, you're back at 25 miles per hour. If you average all of those together, that's your average speed. Instantaneous speed is what happens when your parents get a speeding ticket. It is when, kind of like when the cop does the laser gun at the car, and it gives the speed at a given point in time. Okay, you need the first three on here, just the first three. Okay, accelerate or acceleration is the rate of change of velocity. It can occur with a change in speed, direction, or both. It's when you're speeding up. Decelerate or deceleration is negative acceleration. It's when you slow down. And the equation for acceleration is final velocity. Velocity is the same as speed. So final velocity minus the initial velocity divided by time. Okay, here's a question for you all. If a car is traveling at 50 kilometers per hour, so that's its final velocity is 50. Okay. Oh, I'm sorry, that's its initial velocity. Okay, and slows to 42 kilometers per hour within 30 seconds, what is its rate of acceleration? So its initial, I'm sorry about that, I totally messed you up. The initial velocity is 50. Okay, your final velocity was 42, and your time is 30. So you take the final velocity, 42, you subtract the initial velocity, which is 50, and you divide by, in this case, 30 seconds. What is its rate of acceleration? In this case, you're slowing down. So it's actually negative 0.26. Okay, combined velocity is the total speed of an object, and you need that one also. For example, you row a boat upstream at 5 kilometers per hour with a current pushing you an additional 2 kilometers per hour. So your total velocity would be 7 kilometers per hour. Okay, remember okay, you're going to have to go back and forth with this. First question is speed, distance divided by time. So with this one, get out a calculator, use the one on your phone. I want to see the answers to these oops, so sorry about that. As best as you can on a sheet of paper. At least attempt them so that I can see what your problems are. Okay, so suppose you ran 2 kilometers in 10 minutes. What would your speed be? Distance 2 divided by time 10. For number 2, an inline skater traveling in a straight line goes from 3 meters per second to 9 meters per second in 3 seconds. What is the acceleration? Final velocity, 9, minus initial velocity, 3, divided by 3 seconds. So 9 minus 3 divided by 3. Okay. Number 3, a car travels west for 240 kilometers in 4 hours. What is a car's velocity? Velocity is the same as speed. So distance divided by time. 240 divided by 4. Number 4, an object goes from 9 meters per second to a stop in 3 seconds. What is the object's acceleration? Okay. Final velocity, 0, stop to 0, minus initial velocity, which is 9, so 0 minus 9, divided by 3. And the last one, we have not done momentum. Please skip number 5. Do not worry about that. Okay, this is back in your notes again. Okay, and if you want, hold on just a quick second. Okay, graphing motion. When you're graphing motion, you're going to get one of these 3 types of graph. Okay, a straight line means that the speed was constant. The steeper the slope or the more angled it is, the faster the speed. A line with any curvature at all means that the speed was not constant. It's sped up, it's slowed down, it's sped up, it's slowed down. And then the distance is always on the y-axis vertical, up and down, and time is always on the horizontal x-axis. So acceleration would be a straight line going upward. Deceleration would be a straight line going downward. And any speed change, it'll be something along these lines. It can just be a wavy line going up and down. It might just continue to go up, go down. But that's what your graphs look like. And these actually showed up on the SOL last year. So make sure you know these. Okay, roller coasters actually come into this lesson, which is pretty fun. Okay, they can be made of wood or steel. The steel ones are faster because the steel is more rigid. Any drops, and this is what's important, these second and third bullets. A drop, meaning you're going downhill, means you're accelerating due to gravity. So this one right here, this is Apollo's chariot, I think. Okay. As you're going down, not only are you, you kind of had a little speed coming up here, but you're accelerating mainly due to gravity. Gravity's pulling you down. An inverted loop, so, when you spin upside down. Okay. Turns always cause acceleration, always. Whether it's a turn in the road, whether you're going into a loop and down from the loop, like down here in this picture down here. I don't know if you can see that little loop here. Anytime you have any type of turn, whether it's like this, you're accelerating, or like over here, how you're accelerating here. Any turn means that you're accelerating. And that makes it feel like a force is pushing you towards the side of the car. So you get the G-force from that. Okay, and these 5 questions, I would like you to put on the same sheet of paper as those math problems and be ready to turn them in on Wednesday. Number 1, define motion and give any example at all. Number 2, how is the speed of an object determined? I'm looking for the formula. Number 3, what gives both the speed of an object and the direction it's moving? Hint, it starts with a V. Number 4, what is acceleration? And number 5, why does an object traveling, I'm sorry, I have a typo there, traveling in a circular path at a constant speed accelerate? And that is it. Be ready. We're going to be doing definitely a lab and some graphing work on Wednesday.